solve for Ohm's law. When it came to start using resistors to look after our LEDs, we started running into some problems. So I thought I could put some perspectives into this. So in this circuit, we need 5 volts for this big LED. It's a great big blue LED, puts out lots of lights, very cool. And then we got our 2 little yellow LEDs here that we want to be lit up as well. It's a dash panel or something. So where the students were getting hung up is they needed, by calculating with Ohm's law, 147 ohms here. But they only had a 100 ohm resistor, and they put it in place there. This would supply too much voltage. They would get more than 5 here, which means this diode would have too much power. So it's in strain. It could short or open. And then these guys here are going to have more than 3.3. So they calculated they needed 10 ohm resistors in here to reduce from 5 down to 3.3, so these would have the exact amount of power necessary to run them, and they would have a long life. If we put too much in, we would end up damaging, opening or shorting. So what the students asked is, can we put another LED in here? Or I'm sorry, another resistor in here, and we did have a 47 ohm resistor. So yes, we will put the 47 ohm resistor in. Whoops, that's not a good one. There we go. So we put and we got our 47. So then they asked, what is the resistance of the circuit? We've got a series parallel circuit here. This is the series section, and this is the parallel section. So simply, this adds up to 147, as we could say RT equals RT equals R1 plus R2, and there's only 2, so we can stop there. So we get 147. The rest of the circuit is in parallel, and we're not going to include the LED. It's a very small amount of resistance in an LED, so we're just going to say that it's just a diode, and it allows electricity to flow in one direction. So now we have to calculate the resistance in the parallel part. And quite simply, we can use 1 over RT equals 1 over R1 plus 1 over R2. Now this was a very simple one, so 1 over RT equals 1 over 10 plus 1 over 10. Common denominator is the same. The numerator turns out to be 2 over 10. 1 over RT equals 2 over 10, so we're going to flip that to get rid of the 1. So now we have RT, whoops, big T, equals 10 over 2. So RT equals 5. So there's 5 ohms of resistance in this parallel circuit. So if we drew it, we would have a 47 ohm resistor, we would have a 100 ohm resistor, and then the parallel part of it worked out to 5 ohms. So now we know the total amount of ohms, which is 152 ohms in our circuit. We can divide that into 12 using the Ohm's law triangle. Once again, E, I, R. We got 12 volts, and we've got 152 ohms of resistance. And we can figure out the average that needs to flow in this circuit. So we can see if we're doing Ohm's law, or if we're actually using resistors, it works out the same way. You're going to have to draw this out. You're going to have to add up your resistors in series, and you're going to have to figure out your resistances in parallel so that you can get the average in the circuit. So now we'll do the math, and we'll figure out how many milliamps. Once we divide 152 into 12, we will get that answer, and then we will use that much of a source. I hope you found this helpful.